Hello, everybody, and welcome to the Cisco Community Live event. Today, we are going to talk about Cisco SD-WAN policies and about how those policies can help you to leverage the full power of Cisco SD-WAN. My name is Hilda Arteaga, and I am a community manager of the Cisco community and the host of today's event. So before we start, first of all, I would like to thank all of you. I know these are crazy times, but we really appreciate that you guys are here with us today. So the Cisco community is an online forum with over 500,000 members, and you can get answers to your technical questions prior to opening cases with a tag. And also, you can post or create questions and contribute with documents, videos, and blogs. And you can rate all of the content that is available in the community. Okay, so before we start, I would like to talk and share with you some of the news and upcoming events that we have on the community. So first of all, we have a Ask Me Anything session following this event. This is a forum session that is going to be connected to this webinar, and the way it works out is, let's say that if you, after this presentation, think about something that either Daniel or David mentioned during the event, then you just can go to this forum session and post a question. Also, if by any chance we were not able to answer to your question during this event, please don't worry. We will be posting that question just right there, and the experts will be helping out to clarify it. This session is going to be open till April the 3rd. That's a Friday. So make sure that you just go right there. And also, you can start your questions from now. You can start posting them from now. And also, as many of you might know, and if you are not aware yet, due to this contingency and the COVID-19, Cisco is offering collaboration solutions and security solutions for free so people can do remote working. And because there are too many people having questions related to these technologies, we have scheduled special events that can help you out to clarify all your questions. So firstly, we have an event about how to secure remote workers. And here, like Cisco expert will help you to clarify all the questions about VPN, AnyConnect, Cisco Umbrella, dual security, and all the solutions that Cisco is offering. So if you are new with these solutions, you have never used them before, but you are looking to use them, this is a perfect alternative to go and clarify your questions. Or even if you are someone who are working with that already, but your customers are having questions or you need some assistance, we place this forum for you. All the details for the events and the information that I'm mentioning, you will be able to find them on the chat panel, which is usually located at the right side of your screen if you're on a desktop, or in the three dots that you have if you are in a mobile device. And also, we have the same initiative for the collaboration. We have how to use WebEx meetings. This event is going to be available as well till April the 3rd. So if you're looking to use WebEx Teams, WebEx Meeting Center, and all the endpoint calls, you will be able to clarify those questions as well. And we would like to invite you to become a top contributor in the community. We encourage and we recognize people who are just helping others in this community. So you are more than welcome to start participating. And, well, how can you do that? Well, there are different ways to do it. First of all, it's like helping people with their questions or even creating questions. And also, if you have any content and you wish to share with someone else, if, let's say, you publish a blog, a video, maybe a document, that's a way to contribute. And we encourage you to do that. And if you cannot contribute, just please help us out to rate the content that you see in the community. Why? Well, that helps us to identify high-quality content and also to say thank you to people who are helping us out. The way to do it is very easy. You just see this helpful vote. You just have to click on that start, and then you will get that helpful vote or provide it to someone who has helped you. Or, for instance, someone helped you out to clarify a question, and the answer they provided you helped you to solve that issue. Then you can click as accepted solutions. So in future, if someone has a similar problem, they can see that that's the solution for that issue. Okay? So let's say that you find very useful all the information that Daniel and David are providing you, then you just can give a helpful vote, for instance, to the slides of this event or to the event page of this event. I'm going to start to introduce you to these two famous guys. You might know them because of social media or Cisco Learning Network, or they're everywhere, actually. So I'm going to start with Daniel Deeb. So Daniel is a senior network architect at CISA. He works with creating scalable, modular, and highly available network designs that meet business needs. He started out his career in the implementation and operations field. Daniel obtained his CCIE certification in 2012 in May 2016. He became the second person in Sweden to get a CCDE certified. Daniel has been recognized as a Cisco designated VIP by the Cisco Learning Network for several years, and he often acts as a subject matter expert for his customers with deep expertise in routing, switching, multicast, and fast convergence. Daniel holds a CCIE in Enterprise and a CCDE. So Daniel, and plus the fact that he's a Cisco champion as well. Daniel, welcome to this event, and thank you so much for joining us today.
Thank you, Hilda.
Thank you. And then we have David Peñaloza. He is a senior network consulting engineer at Verizon Enterprise Solutions in the Czech Republic. Previously, he worked as a network support specialist in the IBM Client Innovation Center in Czech Republic as well. And David is an expert interested in all topics related to networks. However, he focused mainly on data centers, enterprise networks, and network design, including SDN. David has a long relationship with Cisco, and he has been an instructor for the Cisco Academy and was recognized as a Cisco champion and Cisco designated VIP since 2017. David holds a CCNP routing as well, CCNP Enterprise, CCDP, and CCNA and Fiber Ops. Welcome, David, and thank you so much for joining today's session. Okay, so for all of you who would like to have a deeper look to this presentation and the slides, you can check them out in the Cisco community. They are already there, so you will find the link on the chat to have a quick look. And I would like to remind you can submit all of your questions starting from now. Please use the Q&A panel that help us out to clarify all of the questions easier. And please use the chat for logistic questions like I have no audio, my screen freeze, or I would like to contact someone. That will help us out to organize better. So I'm going to give the microphone and the presenters role to David so he can help us out and drive us through this topic.
Well, hello, everybody, and good afternoon, good morning, good night, depending on which place in the world you are. And thanks for being with us in this webinar about SD-WAN. Today we'll talk about TLOCs, we'll talk about routes, we'll talk about the policy framework, and in which way you can use control and data policies to achieve business outcomes, being scaling the solution because one of your requirements is scalability, or providing a better user experience because you want to enhance the quality of experience that all the users would have whenever they are implementing any other solution, being collaboration or any other solution that you want to put on top of the SD-WAN solution. The main point being that you would provide a service and you would use the tools provided by the solution to achieve all these outcomes. Okay, so we have our first following question. Do you have any experience with Cisco SD-WAN policy framework? Take your time to say yes or no, I would say. Okay, let's continue with the first topic. Now, as we were talking about the policies, it's important to go over the solution component, at least in a brief moment. So we just give a quick review of all the things we will be talking about. The SD-WAN architecture is composed of 4 elements, and these 4 elements, or at least these main 4 elements, would operate in different planes, each one of them. The first of the elements being vManage. vManage creates policies and templates, allows you to keep control of the solution, to tell the devices what to do, put the configuration there and push it down to all of them. Have a main point of not only management of the solution, but also monitoring. You would get information about what occurs into the network, and you would be receiving intelligence from all the devices joining the overlay, with the goal of being the single point of management and monitoring, and to get all the information we need about our network, to understand what is happening and why it's happening. And on top of that, it provides you with programmatic interfaces. So you don't need to do everything over the GUI. You can use the APIs and automate some of the longest tasks, or at least some of the most repetitive tasks. vManage operates on the management plane. Our second element would be vSmart. vSmart is our control plane node. It handles everything that has to do with routing. It calculates which one is the best route. It hosts the state of the network, it hosts all the routes, and then distributes all these routes using overlay management protocol, the control plane protocol for the solution. On top of that, vSmart collaborates, or not collaborate, but facilitates with the encryption process between the edges, or between the edge devices, by distributing the encryption keys. So the IPsec tunnels can be established between them. And also, it propagates all the policies using OMP. Whenever you create a policy in vManage from the management plane perspective, it will be pushed down to vSmart, who is operating on the control plane, and then vSmart will push it down to all the devices in the network in the overlay using OMP. So it will get to all of them as a routing update. The third element operating into the data plane is the edge router. The task of the edge router are implementing data plane policy, anything that has to do with traffic manipulation. Let me just put a QoS policy in place. Let me just put another packet marking, shaping, policing, anything that I would do into the data plane, to the traffic that I am servicing and the traffic I am delivering from my customer from point A to point B. That's where edge router operates. And lastly, one of the planes that is usually not seen nowadays, or at least it's not commonly mentioned, is the orchestration plane. vWAN operates on the orchestration plane. It facilitates the connectivity and the onboarding on all the devices that are trying to join to the overlay. It's the first point of authentication. So every device trying to join the overlay will first communicate with vBond. vBond will check the information if everything is configured properly, if your certificate is correct, your identity can be confirmed, your company name or your organization name is correct, site ID and system IP. Once all this information is correctly configured and vBond can confirm that actually everything is right, then you will be onboarded into the overlay as an edge router. Once you get onboarded, then the vBond itself will tell you, okay, these are the IPs for the other controllers. So it will not only work as an onboarding device, but also it will allow you to communicate with the other controllers without your intervention. You will get all that information once you are onboarded. This is part of this orchestration plane, this task of facilitating not only the access or the onboarding while also introducing security, but at the same time removing all the intervention from the user when it's not required. On top of that, vBond also operates as a stun server. It will allow or facilitate NAT traversal. Whenever our devices are behind a NAT implementation, being a static NAT or dynamic NAT, or maybe when it's called full cone NAT or full cone restricted cone. Whenever our devices are behind several flavors of NAT, vBond will act as a server, allowing them to first inform them what are their public IP and private IPs and public ports and private ports, and then it will send this information to the other devices so they can establish it to the right interfaces. And on top of that, if the communication is at some point inhibited because of the NAT implementation, then it will simply be the bridge between both of those devices, then facilitating this NAT traversal. Okay, so how does it look from the overlay perspective? Let's just remember that all the SDN solutions work in a way that the abstraction will play a role in the deployment, and also in the deployment, but in the operation. Although it's a fairly complex solution, because under the overlay there are several transports and providers and communication happening, what the user would see is just an abstracted view facilitating the management. It is exactly what the solution is showing you from the overlay perspective. You would have your servers, well, in this case, your controllers that are deployed as just VMs, and they would be hosting the control plane. In this case of our drawing, would be vSmart at the top. And then you have your vEdges, or your edge devices, my apologies, connecting with them over TLS and DTLS connections. These are control connections securing the control plane and IPsec tunnels between the vEdge devices, so the data plane is secure. Quite important to highlight, the communication from the control plane perspective occurs between vSmarts and vEdges, or between vSmarts themselves, but it doesn't occur between the edge devices. It's only towards the controllers. It doesn't go laterally. So my data plane communication occurs between the edge devices and my control plane between the controllers and the edge devices. Okay, so which kind of routes can we have? The first type of route that we would use, or we will hear a lot, are the TLOCs. The TLOCs are routes connecting to locations, connecting to physical locations. They are simply your next hop. And as any control plane information that we will have in the network, it will be advertised to to vSmart. Using what? Using OMP, using our overlay management protocol. What are the attributes of the TLOCs? The TLOCs would have information that we would use to facilitate not only communication, but also to implement policies. They would have site ID, encapsulation, the public IP, the private port, private IP, VFD status, and also a tag and possibly a weight, depending on what are you implementing. All these are simply attributes. Sounds like BGP, right? It's very much like BGP. What are the vRoutes? The vRoutes are anything that our edge devices are learning from the local service side. Some people might ask, but what is the service side? The service side is simply anything connected to my LAN, anything that doesn't belong to management or to the underlay, meaning our VPNs over to our customer. This information is advertised also to the vSmart controller, and well, as you might imagine, they also have attributes. One of the attributes is the TLOC itself, site ID. We use labels to differentiate traffic and offer end-to-end segmentation. On top of that, you can apply a tag, and you can also apply a preference to influence the inbound traffic flow. And as OMP is understood to be a protocol running into an overlay, it will carry information from other protocols, because it's known and it's assumed that the information that we'll have in OMP might come from some other sources in the underlay. Therefore, the origin protocol, the origin metric, and the AS path is information that we would get carried into the vRoutes as attributes. Whenever I redistribute anything into SD-WAN, part of that information is kept so we can apply policies based on matching this information. This is not lost. Actually, even furthermore, it's not even lost, it's respected. It's used as one of the identifiers so we can apply a policy. Okay, Daniel, now it's up to you, man.
Okay, so David mentioned that we have our standard routes. We also have something that's called service routes. So service routes are routes that are advertised for specific network services. So let's say that you want to implement a load balancer or a firewall into your network and you want to force traffic through that device. Normally, this can be quite difficult based on just IP forwarding, because you're just going to forward traffic based on the IP destination. So in Cisco SD-WAN, we have the service routes, which is something that you advertise to the vSmart controller through OMP. And this service route is not distributed to the other edge devices, so it's just sitting there at the vSmart. And we have a couple of important attributes here. Firstly, we have the VPN ID, and then we have the service ID, which is the service ID is what is identifying the service. It could be something like firewall or service 1 or service 2 and so on. And then where the magic comes into play is the label. So some of you may have some experience with MPLS, and it's a very similar concept here where we use a label to force traffic through a path it wouldn't normally take. So when we advertise the service route to the vSmart controller, we're going to take routes advertised from the branch and modify those routes before advertising them to other branches. So we're going to change the next hop of the route, and we're going to tell the edge device what it should use to forward traffic through the service. So that means that if traffic normally would flow directly through a hub device without passing the firewall, by setting the service label, we're going to force traffic to the firewall. The firewall is going to send the traffic back to the hub device, and then it's going to forward the traffic onwards to its final destination. Okay. So now let's talk about colors. So the colors is not only a tag. A color is what we use to identify a physical transport. So when you connect your interfaces to a service provider, which could be an MPLS provider or an internet provider or metro provider or something like that, we're going to map the interface to a color. And depending on what color you configure, we're going to use either the private or the public IP address to establish tunnels. So some of the colors are private and some of the colors are public. So for example, a private color could be MPLS or private 1, private 2, and so on. And a public color could be BIS Internet or red, green, gold, silver, and so on. And different colors, as I said, may or may not, depending on the policy in place, establish IPsec tunnels between different TLOCs. So here you have an example of 4 different TLOCs: MPLS, Internet, Gold, and Silver, where MPLS is a private one and the other 3 ones are public colors. So moving on, by default, we're going to try to form tunnels over all transports, meaning that if you have a site with, for example, gold and silver, gold is going to form a tunnel with both gold and silver towards another site unless you configure the tunnels to be restricted. So of course you need to have reachability in the underlay for the tunnel to be able to form. So MPLS TLOC wouldn't normally be able to reach internet-based TLOC, but if you have 2 internet transports, then normally they would be able to reach each other because all of the public IPs will be available over all of these service providers. So the consideration here is that you have the tunnel scale, because if you form tunnels between different colors, you're going to use up more tunnels, and you have a certain amount of tunnels that each device can handle, depending on what device you have. So you need to consider this for your tunnel scale, but you can also gain some resiliency by using this. So for example, let's say that you have a site with 2 routers, and one of the routers is connected to the gold transport and the other router is connected to the silver transport. Now, if you have a single router site with only the gold transport, if the dual router site is having an issue with its gold transport, then if you don't form these tunnels between gold and silver, then the traffic would be black-holed between these 2 sites. But if you allow these cross tunnels to form, then you would still have a path through the gold transport at the single router site to the silver transport on the dual router site. So by default, we're going to form a full mesh, but we can also set the color to be restricted. And this is most commonly used on private transports, such as MPLS, because you know that it's not going to be possible to form a tunnel between a public TLOC and a private TLOC. So there's no idea in even trying to do that. So normally you would configure those TLOCs with restrict. There's also a more advanced concept here with tunnel groups. We're not going to dive into that today, but you can be even more granular if you want to form groups of tunnels where you want to, for example, form tunnels between some colors but not others. So you can get even more granular than this. Okay.
Gotcha. Thank you, Daniel. Okay, so let's talk about the SD-WAN policy framework. Because we have been mentioning that there's a way in which you can place your tunnels, there's a way in which you can limit them or not limit them. They can be unrestricted or restricted depending on the policy in place. So what exactly do we mean with policies? Let's just review the policies then. We have two kinds of policies. We have the control policy, which is anything that would be modifying routing information, prefix handling, filtering, redistribution, or even my VPN membership in the way that I build my VPN topology. It's a full mesh, it is a partial mesh, it is a hub and spoke. What is it? That's what my control policy is for. But what about my data policy? My data policy would work into any modification affecting the data forwarding. So if I would place any marking into the packet, I would designate a specific transport to be forwarding the traffic towards, or if I would apply application-aware routing. We'll talk about application-aware routing in the later slide. It's a special kind of policy. So the policies can be provisioned in two ways. We can have a centralized policy, and decentralized policy is simply push from vManage down to vSmart. So it would just push it down using a netconf transaction. And as we're using netconf, the configuration stays into vSmart as a current configuration. And then vSmart will advertise this configuration down to all the VHs, or sorry, to all the edge devices using OMP. So it will get to them as a routing update. But what about a localized policy? A localized policy is pushed from vManage directly to the edge device using a netconf transaction. So what's the difference? Whenever we get a policy pushed to the edge devices using OMP, we get a routing update. This routing update will be stored into what is called the volatile storage or the policy RIP. Whenever you get a policy push using OMP, you would get it temporarily stored into your device. It will be just floating there in the OS, and it will work, or it would act as an extension of your RIP, as an extension of a routing table. That being said, whenever the device is reloaded, this configuration is gone because it was actually just floating there in a volatile storage. But what occurs when it's done via netconf? Netconf will simply push the configuration down to the device into the permanent storage. So it will simply be the same as pushing a set of commands and then committing the configuration, which means that it will stay there. One of them is volatile or is temporary, and one of them is permanent. So what are exactly the differences if it's centralized or localized, what you can change with them? If it's a centralized policy, you would do exactly as we just mentioned before. You would play with peerings and routing protocols, and you would do filtering, tagging, announcement, VPN membership, and whatnot. But if it's a localized policy, you have then a limited set of things that you can change, maybe your OSPF or VGP peerings, for example. Whenever we talk about a centralized policy, then we talk about packet marking or transport forwarding or application-aware routing, policies in which I would check information into the packets and then make a forwarding decision based on that information. Is it the right application? Is it the right DSP marking? Should I put another marking? Should I forward it through some special transport? Should I check if my SLAs are being met or not? But this is a centralized policy. In my localized policy, I will be able to change a couple of things, maybe ACLs and some QoS configuration, traffic shaping or traffic policing. So there is a limited set of things that I would do with localized policies. So just to putting them into comparison, the control policy would allow us to manipulate and manage route information. So services into the fabric or into the overlay will be enabled by using the control policies. Some of these services that we can enable, all of them would depend on my control plane information, which means that we can put service chaining in place, or traffic engineering, extranets, or we can simply create arbitrary topology, as I mentioned before. It could be a hub and spoke, or partial mesh, or full mesh, or any other thing that you want to build. And of course, one of the typical use cases is connect discontiguous data planes. We would go into a little bit more detail later today for this. Now, talking about data policies, what can we do with data policies? Well, as opposed to the control policies, data policies, data have specific interfaces or any, I would say, the vector that we would follow. There would be VPN-wide policies that would only apply to a specific set of devices that belong to a specific VPN. These services that we can enable can be application pinning or NAT and dedicated internet access or direct internet access, or this could be classification, policing, and marking using QoS. So it depends on which one of these services we want to put in place into the specific VPN. So keep in mind that we have VPN and Fabric, and my services will depend on which scope I would apply my policies on. Continuing with policies, what's my general workflow to create a policy? I would first create a list, and this is quite important. The whole solution is based on lists. So I would need a list of applications, a list of sites, a list of TLOCs or colors or prefixes or SLAs or even VPNs. Once I've created all the lists I need, then I would decide what I want to create. Do I need a control policy? Do I need a data policy? What exactly do I need? Then after that, okay, let's just put some order on it. What is more important? Which one are specific things and which things are generic? Which order should I follow? In the same way we were building earlier in the Cisco lingo before, a route map. We'll just go from the top to the bottom and then defining the match statements. What exactly am I matching for? Am I trying to find a tag? Am I trying to find an AS path? Am I trying to find a specific site ID, color, TLOC, or prefix? What exactly I'm trying to find? So it could be a route, a TLOC, an application, or even a source destination prefix or a protocol. And then I would define an action. If it's a set, so should I put new information into my packet? If I find any route coming or going to a specific IP address, should I change the next hop in my TLOC? Should I put a new preference on it? Should I put a new tag? Which one is my TLOC list? Should I put it there? Is there a new service, or do I have a DSB value I have to set there? And then I will decide if I want to accept or reject the information I'm receiving. Lastly, we just apply the policy and specify a direction, in and or out. Any of them. You can have one policy in and one policy out. But what's the difference between in and out? And then the next question is, in and out whom? In and out of whom? Which device? Which perspective? Well, let's talk about in and out now. So whenever we say in and out, we are meaning from the perspective of one specific device. All our policies, our control policies, will get applied in the vSmart, in our control plane node. Our control plane, well, maybe sounds redundant, but controller. So whenever we say in, we mean into vSmart. So then following this logic from the left to the right, then all the routing updates without my policy being applied will just get into vSmart. And vSmart immediately, when getting the policies, will apply when getting the prefixes or the updates, would apply the policy and everything will be sent out with the policy already there. Whenever we say out, we mean after we have got all the information and right at the moment of sending things out, we will just apply the policies there. So it will really depend on your use case. Do you want to filter the information before getting into the routing table? Or do you want to filter the information when it's already in the routing table, but before sending it out? It depends on what are your needs. Which one is your corner case? Considerations are important here. So once again, the policies are applied from the vSmart's point of view. A centralized policy will be composed of several subsets of some other policies. So it's not that we have just one policy now. We have a policy composed of many small policies. So as an example, in a data policy, I would have up-route policies, or I would have a CFlow policy. I would have specific data policies and VPN membership that work into my control policy. And on top of that, I will have then my control policy per se. So we have several sets of policies that are working together to provide us the services we need. There is not only one. There are several of them all just coupled together, depending on their functions. You can only apply one policy, or one type of policy, to a per site list. So if you have a site which is getting one policy applied, it cannot get another policy applied in another list. So keep this in mind when you're planning your solution. When you do, or when you create your list of sites, then you would understand that one site can only belong to one specific list. Sometimes it's complicated because you might just miss the numbering, and then you say, well, from 1 to 1,000, and then to 1,001 to 1,999. And sometimes there is one site, maybe it was the 1,001 and it wasn't supposed to be on that list. And suddenly you're matching it on two different lists because you believe it wasn't one and you apply it to another. Just keep in mind your numbering of the sites, and also remember that a site list can have 1, 10,000, 10,000, and myriad of number of sites. And your minimum policy application is a site ID. So there's nothing smaller than a site ID to apply a policy, which means that if I have two devices in a site, all of them will have the same policy because it's assumed that they come from the same place. Oh, yeah, I almost forgot this. You can have a different control policy per direction. So you can apply some filtering in and then another filtering out. Does it make sense to you? Well, it really depends on if you need it or not. Just keep in mind that you can have both of them, and also always remember, because this is quite a common situation, that the policies would be applied from the vSmart's point of view, not the edge devices, the vSmart. Okay, specifically for these policies signal here, there is no duration applied to them because they apply for the VPN itself. They are VPN-wide policies, therefore no duration implied. Okay, so our control policy structure looks like this, and we have quoted this and put the source into the bottom. There's a Cisco Live session covering these specifics. Our control policy structure is based on, if you see our left, we have the sequence numbers and things that we will be defining before bringing them up into our policy. Because in the left side, then we would have all the definitions. What are we going to match? And all the information that we can match and my action. And then on the right side, then you would have a sequence in which you can match route information, and in the left side we have TLOC information. So see that we can actually match in more than a couple of things. If we can match in TLOCs, we will just match all the attributes that the TLOCs are having. If we are matching into routes with a vRoute, then we have another set of attributes. So just keep in mind that you can match many things, and it gives you quite a high degree of flexibility. But at the same time, if you go to flexibility, it could get complicated. So try to put a standard on it. Okay, we have our second polling question. So if you need to modify the topology of the overlay, which policy should you use? Are you applying a control policy? Are you applying a data policy? Are you opening a tag case? Let us know.
Hi, David. So before I open the second poll question, I just sent out the results from this first one. So I don't know if you would like to comment something. Can you see the results?
Yep, let me just double check it here. And do you have any experience with the Cisco SD-WAN policy framework? Ooh, seems like most of the people actually don't have experience with the policy framework. Well, then you're in the right place. We are here to help. That's fantastic. For the second question, well, it's still running. So, well, let's just wait a couple of minutes till you guys are doing the answering, and then we can cover it in a later slide.
Yep.
Okay, awesome. Thank you, Ella. Okay, so now for the next section, let's talk about how to use your control policies to modify the topology. And I actually gave you the answer for that question. I think that was a very dumb move. But anyway, the answer is there already. Let's talk about the first thing that we would get whenever the solution is installed. Out of the box, the solution would have a full mesh type of topology. We will establish tunnels over every transport and aiming to every transfer from our other devices, which means that we will source everything from every transport and we will destine the traffic to every transfer from my other peer. So it's simply an exponential growth. My apologies. Full mesh is awesome. Full mesh is fantastic. Why? Because it's optimal. Because, well, it's optimal and it looks amazing and everything will work fantastic. But what are the downsides? It's quite expensive and also it's not scalable. Whenever you add a new device to your topology, then you will have to modify all the other devices. It gets complicated. What did you get? Well, you get optimality, but at which price? So it depends on what are your needs. This is our default setting. So the point to consider here, as Daniel mentioned before, is that each one of the devices of the solution, being an edge router, hardware VH or software VH, doesn't matter, will have a limit of tunnels that it can establish. Therefore, if I just leave my solution running on full mesh mode, it means that my limit of tunnels will grow. Well, not my limit of tunnels, sorry, my tunnel count will grow quite fast, and then I will reach my limit of tunnels in quite a short amount of time. So what do? You have a trade-off between optimality and scalability, so you can grow the solution or scale the solution better. So which one is an alternative to a full mesh? You can have a regional full mesh. So do you really need a full mesh within both regions, assuming you have two regions? Probably not. So how would you configure it? Well, you first would select which one of the devices in your regions is a hub. See, we got two selected here. Awesome, we have a hub. So now what do we get whenever we have a full mesh? Having a regional full mesh allows us to, well, sadly, lose a little bit of optimality. But what are we getting? We are getting a lower cost. It's simply cheaper. We don't have that many links. We don't have that many connections. We don't have that many tunnels. It means that the devices will, well, we just hold all the information without having to pay a bigger box. And on top of that, it's more scalable simply because I'm not getting to my tunnel count, or at least to my limits into a tunnel count for devices. Some devices might have 250 tunnels as a limit. Some devices might have 1,000, 2,000, and up to 6,000. So plan your tunnels and your connections carefully. The reasons we are asking this is because there are questions that you might ask yourself whenever you are designing a solution. Do you need a full mesh within all the regions? How many diverse transfers do you have? Because there will be a tunnel per transport. So now the numbers start to just pop up, right? So if we have two transports and two devices, that would mean 4 tunnels, only between 2 of them. What if the count just rises between several devices? Then my number of tunnels would just get too high. So how important is really being optimal versus being scalable? Do you really need an optimal traffic flow between one region and another? Probably not. And where are your applications hosted? Usually the applications are hosted into a specific hub. So most probably if you have reachability to your regional hub, that will be enough for you. So just proper planning and you will be ready to go. Another option, even if the regional full mesh is not enough, because you might have lower end devices, is to have a regional hub and spoke. So you have something along these lines. It will be a 2-tier, and you will have a hub per region, and then all the spokes. What will be the disadvantage for this? Well, you will even lose more optimality because all your traffic flow will have to go to the hub and then down to another spoke. You get something positive. Yes, you do. There's lower cost, and it's way more scalable. All the devices will have only one tunnel. But what if we need a middle ground? Maybe this is too conservative. Maybe we can allow some of the sites to have specific communication from a spoke-to-spoke perspective. Not a problem. We can have a 3 tiers. See, it's just our previous 2-tier, and then we just add another tier. Assume that we have tier 1, 2, and 3, and then suddenly, boom, my devices in the tier 2 can create tunnels and connections between them. See how awesome it is? They will have spot-to-spot kind of communication, and anyway, the devices in the tier 2 will have their single tunnels toward the hub. So you would select which devices can actually can handle the load. And then, if you need this communication to occur, maybe the devices on the middle tier, the tier 2, would not be the most expensive ones, but they will be also not the cheapest ones, right? Something in the middle. And then all the other devices on the tier 3 then will be the ones in the lower end of the spectrum. This would allow you to not only plan your connections and plan your communication properly, but also to save some costs. You don't need to put the highest end device in all the sites, but also not the lowest end. So it's a trade-off between optimality and scalability. Okay, so how do we connect these contiguous data planes? This is something we have mentioned earlier. So whenever you have devices that have a different kinds of transport, let's assume that you have one country in which you only can have internet connection. There's no MPLS available because your provider is not able to, well, provide it. So what do? Well, not a problem. You can have a set of devices only connected to MPLS and another set of devices only connected to MPLS. What do? You would designate one hub in the middle that will be dual home. So we'll just pick one device. One, of course, it needs to be beefy. So one device with higher capabilities, and it will be connected to both of the transports, being internet and MPLS, and then this device would be the bridge. So the communication will occur through this hub we have designated because it's the only device with, just said in another way, 1 feet in each one of the transports. 1 foot, was it? So the data plane tunnels will be just formed between the between the edge devices, but how? They will just simply go over the hub. And well, now let's talk about data policies. Daniel, all yours, mate.
Great work, David.
You should be receiving that one. So in the meantime, you are sharing. I'm gonna share the result, the second polling question. So.
Yeah, I see the answers. Yeah, well, most of the people was clear. It's the control policy. Awesome, excellent. That means nobody's sleeping yet, right?
Not yet.
Perfect. Okay, so let's talk about data policies. Okay, so as opposed to control policies, the centralized data policies are VPN-wide, so you can't apply them to a specific direction, like David mentioned for the control policies where you apply it inbound or outbound. The centralized data policy is applied VPN-wide. There's no direction. You can still apply different policies to different VPNs, different sites, and so on. You still have that granularity. It's applied on the vSmart, just like the control policy, and then it's advertised to and executed on the WAN edge. So this is a bit different than a control policy, which is basically just modifying attributes on the vSmart and then advertising them. So the policy is actually executed on the WAN edge itself, which makes sense because you're doing stuff in the data plane as opposed to the control plane. So some of the possible services in a data policy is application pinning, meaning that you want to send a certain type of traffic on a specific transport. You can use it to leverage a local internet breakout to send, for example, cloud traffic and internet destined applications on your local breakouts. You can also do all of the traditional QS stuff like classification, policing, and marking. So the structure looks something like this. From a pure CLI perspective, it's going to look a bit different in vManage, but this is just to show you what kind of attributes you can match on. So as you see in the top, you're going to name it something, data policy and the name. Then you're going to apply it to a VPN, and then you have sequence numbers. So if you have done route maps in the past, similar logic here, where you start from the top with the low sequence number, and then move onwards to the higher sequence numbers. So you can match on a lot of different things here. There is the application list, where you where you're going to use a DPI engine to match on applications. You can match on different prefixes, and you can match on DCP values, protocols, and prefixes. And then you're going to have an action, which could be to set the DCP value or set the forwarding class, which is used for QS. You can also set a local TLOC for doing a local breakout, or you can set a remote TLOC to force traffic to a specific site. And those are the most common things you will do in a centralized data policy. And then you have a default action, so that's simply what's going to happen if it doesn't match any of the previous sequences. So this can be applied in 3 different modes. So you have a very big edge device here to show you the different directions. So the first one is from service, which is also known as upstream, meaning that traffic's coming from the service side, which is your LAN, and going towards the WAN. And then you can also do from tunnel, which is the opposite direction, coming from the WAN and going towards the LAN, and then you can apply it to all as well if you want to do both up and downstream. And the most common application here would be to apply it from service, because normally you want to do something with your packets coming from the LAN, and then before they hit the egress interface, you want to do something like break out the traffic or send it to a specific site or so on. So that's the most common application. And then if you have different policies, you can apply them in different directions if you want to. So as always, there's no fun if you don't need to know the order of operations of things. So if we have a nice diagram here, credit to Stefan Olofsson from his session. You can see the session number here, BRK-RSD 2791, which is a deep dive on policies as well. So the first step when the traffic hits the ingress interface is going to be to go through any local ingress policies. So this is a local data policy, and that's where you would do things like, for example, policing, admission control, or classification and marking. So it's going to hit that one first, and then it's going to hit our application-aware routing policy, which is where you do your forwarding based on SLAs, so defining thresholds based on latency, packet loss, and jitter. So in the next step, you have your centralized data policy, and that's where you do things like application pinning, which we mentioned before, and also you can do path selection. So keep in mind here that if your app-aware routing policy, for example, chooses a certain TLOC, and then you have a centralized data policy that says something else, because that's applied later, it's going to override the decision in step 2. So you need to be aware of the order operations here so that you don't mess up your application-aware routing forwarding logic due to your data policy. So if you haven't applied any policies, then you're just going to follow the normal routing forwarding in step 4. And then on the egress side, you also have the queuing and scheduling. So here is the place for any shaping, or also the weighted round robin and the low latency queue if you're assigning a different amount of bandwidth to different queues, and also if you're using the congestion avoidance mechanism, which is random early detection in this case. And then you also have a local egress policy, which is once again the local data policy. So even if the packet hits step number 6 and you have an access list that denies the packet is going to be dropped. So as you get more advanced with the policies and doing troubleshooting and so on, there's some commands you can use to see this forwarding behavior, especially on the C edge. There's some advanced commands you can use to see what path is being picked from the different steps in the order operations here. So for our third polling question, I'm going to ask you, which policy should you use to configure application pinning with Cisco SD-WAN? So are you going to use A, a control policy, or B, a data policy? Yeah, I see the results. So most of you answered data policy, which is the correct answer. So yeah, good job. So it seems we're making progress here. So I'm gonna close down the poll. Now we're gonna talk about dedicated internet access. So most of my projects, customers now, almost all of them have an internet transport and leveraging a local internet breakout. So there's a few different ways you can design this. I'm just gonna go through them really quick here. So the most simple option is to do a local data policy where you put a static route in the service VPN that points towards VPN 0. And remember, VPN 0 is where you have all of your transports. So that's really simple to use. It's not very granular because it's kind of an all or nothing scenario where you just point a static route towards VPN 0. You can do a centralized data policy where you can leverage several transports if you want to and do per flow load sharing. So that's important to keep in mind. Cisco SD-WAN doesn't do per packet load sharing, so keep that in mind because that can really mess things up. You can end up with some scenarios where your interface towards the provider is online, but they have an issue further upstream in their network. So to kind of protect against a scenario like that, you can use a tracker. Very similar to IPSLA, but keep in mind that the probe is HTTP, so you shouldn't configure it to probe something like 8888 because that's the Google DNS and it may or may not respond to HTTP, so you should configure it to use configure an endpoint that's expecting to respond to HTTP, and you can configure the IP address or host name. So this is basically what it looks like in vManage. It's very simple, just a quad 0 route pointing to VPN 0. You need to have an interface in VPN 0 with NAT enabled. If you have several interfaces, it's going to do load sharing, but you can't do any matching on ports or other attributes. So the more granular option is to use data policy. So you see one here on the right-hand side, which is one of the policies I've been using. So the first sequence here, we're going to match on internal prefixes. So this is quite common when you use a policy like this, that you match on your internal networks, which is normally the RFC 1918 networks, such as 10.0.0/8 and so on. And the action is just accept. That means that you just want to impose the normal forwarding, while in sequence 11, we're matching on destination ports 80 and 443, which is the web traffic. And the action here is accept and then NAT use VPN 0, which means we're going to break out the traffic to the internet transport in VPN 0. So you can match on prefixes, ports, and be much granular. You could, for example, match on Office 365 or other cloud apps, or just send all your internet testing traffic through the local breakout. You can also set a specific transport to use if you want to. For example, if you have two internet transports and want to use one as the primary one and one as the secondary one, you can do that with a data policy as well. So we also have service chaining. I mentioned this briefly before. This is mainly if you want to redirect traffic to a service such as the Umbrella SIG or the Zscaler, which is both secure internet gateway services where you're leveraging cloud-hosted firewalls and proxies to do your filtering instead of using a local firewall. So here we have a policy matching TCP and once again port 8443. And here the action is to set the service to a firewall, and also it's a local one. So we have the local keyword after here because we have a locally configured GRE tunnel towards one of these services. Could also be an IPsec tunnel. So then moving on, we have application-aware routing, and in short, it's policy-based routing on steroids. It allows you to match a lot of different attributes within the IP packets. So among those, we have the source and destination IP, source and destination ports, the layer 4 protocol, DHCP values, and also applications using the DPI engine. So if it's a VH, it's going to use the Cosmos engine for the DPI, and if it's a CH, it's going to be the NBAR2 that's used to match the applications. And after matching, we can forward packets according to certain criteria. For example, we can set a specific transport, or we can also match on certain thresholds to see if we are meeting specific SLAs according to packet loss, latency, and jitter. And this is all measured using BFD. So if we have an MPLS link that's misbehaving, we can send it through another one, or, for example, use the internet transport as a backup. So keep in mind that there's a limit on the number of flows you can have depending on your type of edge device. So be a bit careful with using the DPI engine. Normally, I would recommend to match on something else like pretty simple or even the DHCP marking. And by default, an edge router will use all of the available transports, and traffic will be hashed between them, assuming that you haven't configured a policy to prefer a certain transport. So application pinning is used to send traffic on a specific transport, and if the conditions of the SLA aren't being met, we can use a backup path. That's what's called a loose matching. We can also do a strict matching where if transport such as the MPLS transport is not available, we don't want to send traffic on any other transports. Honestly, I don't see a lot of this any longer where we want to send traffic on a specific transport and then just drop it if it's not available, but it's still common to see MPLS being used as the primary transport for some of the business critical applications, but then leverage internet as a backup. So there's a couple of things we need to understand about the application-aware routing algorithm. By default, we have 6 buckets, which is where we collect all of the measurements from the BFD packets. So normally each bucket will collect 600 of these packets because, as you can see, the default hello interval is 1 second, and the poll interval, meaning the size of the bucket, is 600 seconds. So we will collect all of these measurements, and as I said, we're measuring the loss, the latency, and the jitter. And once we have filled all of these buckets, we're going to calculate the mean over all of these buckets. That means that depending on how much latency and loss you have in the network, it's going to take a while to react to the brown noise scenario. So we have a here showing that it's set to 100 milliseconds, but your current experience 150 millisecond latency. As you can see, as we collect measurements in the buckets for each interval here, the mean is going to be increased, but it's going to take a while until we cross our threshold. So if each bucket here represents 10 minutes, then you can see that it might be up to 40 or 50 minutes using the default values to move the traffic to another path. Of course, this depends on the actual latency and loss that we are experiencing. So here, the latency isn't that bad compared to the threshold. If it was, for example, 300 milliseconds instead, then we would shift the traffic more rapidly to another path. And you can change these values to be more aggressive, but keep in mind that if you're too aggressive, you might get false positive and move the traffic too rapidly to another transport. So finally, we're just going to talk briefly about quality of service. Because of the application where routing, the use of QoS is not always something you need to configure, but in some cases you may want to protect your queues from being starved from other traffic. So this is configured through a local data policy, so it's not the centralized one. It supports policing, shaping, congestion avoidance, and rewriting of DHCP values. So the congestion avoidance mechanism is red, so it's not weighted red. Might be something to keep in mind. And this is basically what it looks like. Packet is going to arrive on the ingress interface, and we can do policing there. So let's say that you have some traffic that we just want to drop immediately or don't want to have it consume too much bandwidth. We could do policing ingress. We can also rewrite the DHCP value. And then we're going to map the traffic into a forwarding class. And the QS forwarding class is going to map to an egress queue when the packet is being transmitted on the egress interface. So then once again on the egress interface, we also have a policing mechanism. So depending on where you want to do the policing, you can do it either ingress or egress, depending on your use case. Once again, we can also rewrite the DHCP if we need to do that. And then, as always, shaping is applied outbound, so you can shape inbound because that's just how you apply shaping and leverage the queuing and buffers. So we have the forwarding classes that are mapping to the egress queues, and we have the QS schedule running, which is weighted round robin in this case, which is pretty much similar to class-based weighted fair queuing in a traditional router. So we're going to assign amount of bandwidth and amount of buffers for each queue. And normally you would configure the amount of the percentage of bandwidth and the percentage of buffers to match up with each other, but you can put different values if you want to. And then we're going to have a drop mechanism as well. So this is what it looks like from the managed GUI. So here you can see that we have 3 different queues. Queue 0 is always the low latency queue. So this is where you would put your voice traffic and also all of the important traffic egressing the router, such as the OMP control plane traffic, BFD packets, and so on, is going to be put into Q0. That's not really something you can control. That's just going to be put into Q0 automatically. And then we have 2 other queues here, and we have configured the amount of bandwidth and the amount of buffers. So this is pretty much what it looks like from the managed GUI. So our final polling question is that with the experience from this webinar, do you think that you will be able to leverage Cisco SD-WAN to implement your Cisco SD-WAN solution more efficiently? So it's yes, no, or basically don't know.
So David has been doing a great job as well answering the questions. There are still some of them coming on.
Okay, so the results is pretty resounding yes or don't know. So we'll take that as a win. So thank you all for joining this session. It's been our pleasure to present here today, and we're gonna continue with the Q&A now, and don't forget the Ask Me Anything available on Cisco community as well. So thank you very much.
Thank you, Daniel.
Thanks, everybody.
Quite a great presentation. So what we're going to do is we're going to try to answer the questions from the audience. So I started assigning some of them to you. So David, we will start with you. I assigned you a question that says every time I implement a new site. I don't know if you can see that one, or if not, I just go ahead.
I'm trying to check it. Every time I implement a new site, only I can configure NAT in the secondary via transport interface and the TLOC extension to the primary, which has the MPLS. Yes. So, yeah, what I didn't get is, well, what is the question all about? Because whenever you implement a TLOC extension, you're simply allowing the other device to get access to your own transport. So in many cases, people will simply extend the internet towards the MPLS and even would be extended in the other way around. But the question is, my question will be, what are you trying to ask in regard to this? Because this is just an implementation, I would say, action on the procedure.
All right. Then, Daniel, I assigned to you one question that says, I have third-party connections that still use LSAs for dynamic failover today, looking for a way to use something like within the service VPN. So what would you recommend?
Oh.
Let's see, I have third-party connections that still...
Yeah, I saw a question actually. He was asking for if it's supporting SLI in the same way we do it in the Cisco way, but in a service VPN. I know IPSLA will be supported soon, but I don't know if it will be supported towards the service VPNs rather than towards the transport VPN as we do with the tracker.
Yeah, I haven't seen it supported so far, so I would guess that it's a roadmap feature if it's something they're going to implement. Yeah.
But then, how would you implement a dynamic failover in a service VPN? Well, you might use just a routing protocol. It's complicated to put anything dynamic if you cannot rely on something like IPSLA or a BFD probe.
Yeah. For the service side, I would prefer to use routing if available, and if it's like a simple site, you would normally do something like VRRP on the service side and fail over locally if one of the devices is not available. So.
All right. So I see somebody's answering that question from Meraki. So then I'm going to jump in and make one question is, how do you provide the best user experience with Cisco SD-WAN? You have already mentioned many options, but at glance, how can you wrap up everything or give a summary?
Yeah, I think the thing to keep in mind with Cisco SD-WAN is that it's very flexible and very granular. So, I mean, for some use cases, you might want to just keep things simple, and in some scenarios, you need to be more granular with the policy. So, but that's what I like about it, that you can pretty much cover almost any scenario you can think of to become well versed in using the policy. So yeah, it's a powerful solution for sure.
Awesome. So then, Daniel, I just assigned you a question that it talks about two transports. So you should be able to see it on your Q&A at the moment.
Yeah, let's see. Okay, so I think the question here is around having two transports, MPLS and Internet, and being able to reach the controllers. So I'm not sure if it's on premises here or the cloud hosted ones, but normally something to be aware of is that edge device will try to form control sessions over all transports, including private ones. So if you have cloud-hosted controllers, normally you won't be able to reach the controllers over that path. You may want to disable forming control connections over that transport, or you can provide connectivity towards the controllers over your MPLS transport, for example, by advertising a default route or the prefixes for the controllers into your MPLS underlay, so that you have a path, for example, through your data center to reach the cloud-hosted controllers. So I have done scenarios like that. It's not that complicated. You need to NAT the traffic because it's going to be coming from a private IP, and you need to NAT the traffic before sending it towards the internet, but it's possible to do it in that way, or simply not use the control connections over private transports. So that depends on if you have internet available at the site or not.
Okay, awesome. So I assigned you another one, and the question says, is the destination NAT supported? So the BS Internet underlane reaches my interface FWS in data center.
I'm not sure what the scenario is here. If they want to NAT the traffic before going to the central site, there is support for NAT. I'm not sure if this scenario is supported. I would bring it to the support community so we can look it up more in detail, because I need to check on some details there.
Okay, so here's another question. On Cisco iOS SD-WAN router policy for TLOC, is that working?
Router policy for TLOC is working. Yeah, you can configure policies for the C edges as well. My experience with the newer code has been very good, so it has matured a lot the last couple of months. So things that weren't supported before, it's pretty close to feature parity to the VH now.
Awesome. So let me see, because David is just like a
Yeah, I'm
quick.
also while he's talking, I'm also writing. So
Yeah. So let me assign that one to Daniel then. So is there a way to use routes from one vSmart to another?
Well, that's not really how you use them, because for those of you familiar with BGP, you can think of the vSmart as a route reflector. So they all need to be synchronized and have the same view of the network, or you could end up with weird scenarios with routing loops and so on. So you wouldn't really, well, you can do things outbound with a control policy. I have never tried to prefer one vSmart to another. I'm not sure what the scenario would be there, but
in general, it's recommended only to apply the policies over vManage. So vManage will make sure that the same policy is in both of the vSmarts. Yeah. So you don't cause any, well, let's just call it an unexpected feature to arise, simply because you have a different set of routing information, and you might even have a flop. What would occur is then there's a flop in a route, and then suddenly it switches from one vSmart to another. It just gets complicated. The main point of having a vSmart and having them deployed in pairs is that you will have resiliency, and both of them will have the same information.
What we didn't mention in this session that could be relevant for this scenario is that you can have different vSmarts for different regions and restrict the formation of OMP sessions. So, for example, if you want to have Europe vSmarts, US vSmarts, and so on for your resiliency design, you can do that, but that's totally different from what we're discussing here. But
okay, so David, I just assigned you a special question. It comes out from the chat. You should be able to see it on your WebEx Teams. Can you help us out to address that one, please?
Oh, hold on a second.
Sure, no problem. In the meantime, Daniel, I have a question for you. This one seems interesting, actually. What is the difference between SD-WAN and I-WAN?
Okay, so I-WAN is what I was configuring 3 or 4 years back, and was based on DMVPN and standard routing protocols such as EIGRP and BGP, and then we had a protocol called performance routing to do similar things that we are doing today. But I would say the main difference there is that I-WAN wasn't designed from the start to have an orchestration and management platform, which is, I think, the big advantage of the current solution, leveraging vManage for configuration templates and management, and having the vSmarts for distributing routes and policies and so on. So there's that feature overlap, but from one point today, I definitely would recommend to go with Cisco SD-WAN and not I-WAN.
Okay, for the question I've got, it is, I need to use a tracker in the DIA route in the CH. So if this internet link fails, you can use the MPLS tunnel to DC and start using the internet from the DC. Okay, so you might have a couple of ways to do it. One of them is, well, yeah, if you have a tracker in the interface, then it should simply disable the reachability over the interface whenever the tracker is not working. And another way would be simply to do it via routing as we have done it earlier. You would just have maybe your default route coming from the data center. I don't know, Daniel, if you want to add something on top of that.
No, I just know that from experience in some releases, I had some issues with the tracker. There was a couple of bugs. So if something is working as expected, then check if it's a bug or not.
Yeah, sometimes it was down and, well, the interface was up. sometimes it's complicated. You have to double check if actually the feature is providing you what it's supposed to give you. And also depends on the version you are. Cisco has some recommended set of versions. I know that at this point you should be running anything in 18.4 because even the 18.3 train is already end of support or end of life. So they just don't want to use it anymore. So also depends on which version you're running, and just keep an eye on if any bug is coming. So check all the advisories using the Cisco website.
Okay, thank you guys. So we are going to cover only 2 more questions. One I have already assigned it to Daniel. It says on CEH, the DIA do not work okay because when the traffic is down for the bit's internet caller, automatic don't commuting for MPLS, sorry. So SD-WAN iOS, what's the problem then?
Yep, I think we need to probably follow up on this one. It could depend on what version they are running, or if the policy is, the configuration is not correct somehow. So I would recommend to post this to the forums. We can look into it a bit more. Yeah, because it should be supported in theory. So yeah.
Okay, so the final one is, can you please elaborate on the 101 net transversion function of vBond?
Yeah, so there's a lot of good presentations to dive more into NAT, but just quickly, I mean, the way it works is that when you start, like David mentioned, the first step is to authenticate to the vBond when you're joining the overlay. So you're going to present your IP address to the vBond. So you're going to say that, okay, I'm coming from this IP address. And then the vBond is going to see where the packet is actually coming from. So if there's a difference there in your private IP and the public IP, then the vBond is going to know that you have been going through a NAT function. And as David mentioned as well, there's also stun functionality, which is another feature used to identify NAT as well. So we can follow that up in the forums to give them some good links to a couple of presentations to dive more into NAT and show the supported configurations and so on.
Okay, well, thank you very much, Daniel and David. With that, we are going to close down the live Q&A, and thank you for all of you who have joined to this session. We know the times are complicated for many, but we really appreciate it. And well, if you have any further questions, or there's a question that we need more information, as Daniel just mentioned, to clarify, remember that you can find it on the Ask Me Anything session of this event. This session is going to be available to Friday, the 3rd of April, so don't worry, there's enough time still. So if you have any questions in future, then you have this alternative as well. And well, if you would like to find further events like this one, you're interested in all the news that we are having, we invite you to have a look to our social community channels, like Twitter, like Facebook. We're on YouTube, we're on LinkedIn, and currently as well on the application that is for customers and partners. And also, if you're looking for a training like this in a different language, for instance, you speak Spanish, Portuguese, Chinese, Japanese, or Russian, then we have different trainings like this one in our local community. So we invite you to access there. And French is our latest community. And also, if you're looking for further IT training, we invite you to have a look to all the seminars, webinars, trainings, and all the content that the Cisco Learning Network is creating. Actually, David and Daniel, they're very top and high contributors in that community, so you're going to find great material there. And once again, well, thank you so much for your time. And there is a survey, a pop-up survey coming out of our emergency survey on your screen. Once we finish this one, we kindly ask you to please help us out to fulfill it. That helps us out to know how we are doing, where can we improve, and most of all, what kind of topics you would like to see in future events like this. And well, for all of you who fill out this survey, actually we have a 35% discount offer. Here's the code. You have to fill out that survey, and well, you can buy any Cisco Press title or educational material. Here are some examples of what you can get, and if you have any issues, don't forget to contact me. And finally, thank you very much, Daniel and David. I wish all of you are well safe, and hopefully we can collaborate in the future.
Yeah, hopefully we can. Thanks for the invitation. As always, it's been an honor to be here with all of you and also, well, sharing the stage with Daniel. Thanks a lot, Daniel.
Thank you so much for taking the time, and thanks for all of the great questions. So let's continue the discussion, and I hope you have a great morning, afternoon, evening, and that you all stay safe and take care.
Thank you, guys.
Yeah,
See you
remember, stay home, wash your hands, 20 seconds.
Thank you. Bye.
Bye-bye.
Bye.